So hello and good morning to everyone. So our today's lead code question is 3161, which is block placement queries. So in this question we are given that we have an infinite number line whose which is starting at 0 and extending towards the positive x-axis, like this is 0 and then we have this number line, and we are given a 2D array named as queries, which contains there are two type of queries. So first type, that is type 1. So in type 1 we have 1 comma x. So that means this is type 1 query. So what we need to do is we need to build an obstacle at a distance x from the origin. So basically we have to build an obstacle at point x, right? And they have mentioned that they have guaranteed that there is no obstacle at distance x when the query is asked. That means there was no obstacle already placed at x when this query was being asked. So this is type 1 query where we are given 1 comma x and we need to build an obstacle at the point number x. The type 2 query is, so in type 2 query we are given x and size. So we have to check whether it is possible to place a block. It is possible to place a block whose size is sz in the range 0 to x, right? Such that the block entirely lies in this range, and doesn't intersect with any obstacle. So suppose if you have an obstacle at 1, so suppose you have an obstacle at 1 and we are given 2 comma, let's say x is 2 and size is 3. That is, it is possible, is it, no, 3 can't be possible, let's say it be 2. That is it possible to place a block of size 2 between 0 to 2, 0 to 2? It is not possible to place a block of size 2 between 0 to 2 because we have an obstacle at 1. So that obstacle is intersecting with this, so we have to return false for this, right? So this is type 2 query. Now what we need to do is we need to return a boolean array named results, where results of I is true if we can place the block in the specified ith query of type 2, and if we can't put that block, then we have to return false, right? So this is our question statement. So let's see some examples to get the question more clearly. So if you see, so this is type 1 query in which we have to put an obstacle at index number 2. So at index number 2 we have put an obstacle, right? Then this is type 2 query 2 comma 3 comma 3. That means we have to place a block whose size is 3, and from 0 to 3, that from 0 to 3 we have to place a block of size 3. So 0 size of block 3 from 0 to 3. So this will be our block. But if we see there is an obstacle at index number 2, so this block can't be placed, so that's why we have put false over here. Then next is 2 comma 3 comma 1. So now the size of our block now is 1, and we have to put from 0 to, in between 0 to 3, in between 0 to 3 we have to place a block of size 1. So we can put a block of size 2 here. So even we can put a block of size 1. So for this we return true, because we can put our block over here, right? Or over here, or between 2 to 3 also we can put our block, right? So there are three places where we can put this block. Then next we see 2 comma 2 comma 2. That is, we have to put a block of size 2 from 0 to 2. So yes, from 0 to 2 we have a gap of size 2. So we can put this block over here, so we have written true for this also. So this is our example. So let's see the next example. So in the next example, first we have put a an obstacle at point number 7. At point number 7 we have put an obstacle. Then the next query is 2 comma 7 comma 6. That is, size is 6 and x is equal to 7. That is, we have to put a block of size 6 in between 0 to 7. So in between 0 to 7 our gap is in between 0 to 7, our gap is equal to 7. So we have a gap of 7, so we can put a block of size 6 in between that gap. So we return true for this one. Then the next is 2 comma 7 comma 5. So here size is 5, and again, like x is equal to 7, so we again can put this block in the gap of 7, right? Oh, sorry, before that we have a type 1 query, so we have to put an obstacle at point number 2, at point number 2, right? So we have put an obstacle at point number 2. Now from 0 to 2 we have a gap of 2, and then from 2 to 7 we have gap of 5. Now we have 2 comma 7 comma 5, we have 2 comma 7 comma 5. So size is 5, and we have to put from 0 to 7. So we have to check whether we have a gap of 5, we have a gap of 5 or more between 0 to 7. Yes, between 0 to 7 we have a gap of 5, so we can put this block, so we return true. Then the last one is 2 comma 7 comma 6. So now our size is equal to 6, so we need a gap of 6, we need a gap of 6 between any two obstacles to put this block between the range 0 to 7. So if we see between the range 0 to 7, maximum gap is of size 5, which is lesser than 6, so we can't put this block, right? We can't put this block, so we put return false for this. So this is example number 2. So let's see the constraints. So the total number of queries is 15 into 10 ki power 4, and the queries of I dot length can be from 2 to 3. If type 1 query, then the length will be 2. If type 2 query, then the length will be 3. And queries of I and at index 0 we have either 1 or 2, that is either type 1 or type 2. And x and size can be 5 into 10 ki power 4, minimum 5 into 10 ki power 4, or maximum 3 into queries dot length. So 3 into queries dot length will be 15 into 10 ki power 4 at max, but in that case it will be 5 into 10 ki power 4. So at max the x and size can be 5 into 10 ki power 4, right? We'll be using this constraints to solve our problem, right? And it is given that the input is generated such that for queries of type 1 no obstacle exists at distance x when the query is asked. So all the obstacles are unique, there are no duplicate obstacles, right? That is, for any point there are unique obstacles. And also the input are generated such that there is at least one query of type 2, will be there in the question. So these are the constraints. So let's start with the approach part. So we have this type 2 query. So in type 2 query, what we need to do, we need to check whether can we put a block whose size is sz in the range 0 to x. So basically that means we need a continuous gap, we need a continuous obstacle free segment, or we can say we need a continuous gap whose at least size should be sz, so that we can put a block of size sz in the range 0 to x, right? So for that is type this is type 2 query. That means in the range 0 to x we need a continuous gap between the obstacle, such that the gap should have at least sz as the minimum length, so that we can put this block, right? So now instead of thinking about putting the blocks, what we'll think about the gaps between the obstacles, right? So let's see an example. Suppose our obstacles are located at 0 2 7 10. Then if we see between 0 to 2 we have a gap of 2, between 2 to 7 we have a gap of 5, and between 7 to 10 we have a gap of 3. So So these are the free segments, or we can say these are the gaps. These are the gaps between the obstacles, right? So when we get a block, that block should fit inside these gaps, right? So for a type 2 query, we only need to know that what is the largest free segment that we have inside the range 0 to x, right? We need the largest free segment, or we need to know about the largest gap that we have in the range 0 to x, right? If the largest gap, if the largest gap is greater than or equal to SZ, is greater than or equal to the size of the block, then our answer will be true. Then we can fit that block in that particular gap. If the largest block size is less than SZ, less than size, then we can't fit the block, so we return false, right? So we have to return false. Understood type 2 queries. So the next thing that we need to understand is that instead of processing the queries in the given order, that is forward order, what we'll do is we'll process the queries in the backward order, right? In the backward order, right? So what happens if we process the, why we do not forward the process the queries in the forward order? So suppose we have the what you called obstacles at 0 and 10. So when we insert, let's say, some obstacle at x point, some obstacle at x point, then earlier our gap was of 10. Now we need to divide the gap in x and 10 minus x, two parts, right? We need to divide the gap into two parts, right? And maintaining such smaller gaps, or maintaining such splits is difficult for us, right? Is difficult for us, right? Inserting that is inserting a new obstacle, inserting a new obstacle is difficult for us. So what we do is we reverse the queries, like we process the queries from and to beginning, and to beginning. So if from front direction, if we have to insert, then from back direction we need to remove, need to remove an obstacle. So what we do is initially we insert all the obstacles that appears to us, right? We put all the obstacles on the number line, right? And then start processing from the last, so in reverse, for type 1 queries, basically we have to, for type 1 queries we need to insert the obstacles, but as we already inserted all the obstacles, so when we come back, from the last, so when we get a type 1 query, that obstacle we have already inserted while going forward. So when we process the queries from the last, then when we get a type 1 query, then we need to remove the obstacle, right? So basically, removing the obstacle means we have, let's say, two gaps, right? Suppose we have 0, we have 10, and we have an obstacle at x. We have this gap x and this gap 10 minus x. So when we remove this obstacle x, now we need to merge these two gaps, so merging these gaps is easier for us, comparatively to splitting the gap. So that's why we are processing the queries in the reverse direction, right? I hope you get this point, right? So it is here, an example is given. Suppose we have 0 to 7, and when we remove 2, we have to merge this gap 0 to 7. So these two gaps, 2 and 5, is merged into a gap of 7. It's like this, that's easy to maintain, and that's why we are processing in the reverse direction, right? So the next thing that we need to understand is, so suppose we have an obstacle at some position p. So what we need to do is we need to store what is the gap that we have at this position p, right? That is position minus the index of the position of the previous obstacle. So this gap, this is the gap at this position of the obstacle. Now if we have obstacle at 0, 2, 7, 10. So at 2 what will be the gap? So gap of 2 will be its current position, that is 2, minus the previous obstacle at is 0. So 2 minus 0 is 2. Then gap of 7 will be its current position 7 minus previous obstacle is at 2. So gap of 2 is 7 minus 2, 5. Similarly we find gap of 10, that is 10 minus 7, that is 3, right? So we find these gaps, right? We find these gaps between the obstacle, right? So so we have positions and we have the gap that is ending at that particular position. So at position 2 we have a gap of 2, at position 7 we have a gap of 5, at position 10 we have a gap of 3. And now what we'll do is we store these gaps, in the segment tree, right? And when we need to process a type 2 query, so basically what we need to find the maximum gap, in the range 0 to x. So basically range updates or range queries, so that's why we'll be using segment tree here, right? So we can easily find the maximum gap from the segment tree, right, in the range 0 to x. So that's why we are storing the gap values, right? And if the maximum gap is greater than equal to size, then our answer will be true, right? So let's see what does uh, the segment tree query will do and how it will happen. So we have seen at gap of 2 we have gap 2, at 7 we have gap of 5, at 10 we have gap of 3. And now suppose we have a query 0 comma 7, from 0 comma 7. So if we see what is the maximum gap from 0 to 7 in the range 0 to 7. So if we see in the range 0 to 7 the maximum gap is 5. So when we query the segment tree a range that is 0 to x, it will give us the maximum gap, in that range. So in the range 0 to 7 the maximum gap is 5, so we get 5 as the answer, right? That is the maximum gap, which is before x, right? So this is what we get from the segment tree query. Now we'll understand how we'll process a type 2 query. What we'll do when we get a type 2 query. So we have considered three obstacles. At 0, 2 and 7, right? At 0, 2 and 7. So here gap is 2, here gap is 5. And now what we need to do is we need to query query of type 2 whose size is 4, and x is equal to 6. That is we have to find a gap, of size greater than equal to 4 in the range 0 to 6, such for fitting this block, right? This is the gap that we need. So what we do is, so we have x is equal to 6. So first what we need to do is we need to find the previous obstacle which is lesser than or equal to x, last obstacle which is lesser than or equal to x. So here we have 0 to 7. So last obstacle which is lesser than or equal to x will be 2. So we get our previous obstacle as 2, right? So the next thing that we need to do is, in step 2 we need to find a largest gap from the range 0 to last obstacle, So here in 0 to the maximum gap that we have is 2. So this query will give us the answer as 2, right? This will give us the answer as 2. Now if you have seen we have 0, 2 and 7, and we have asked at 6, from 0 to 6, and we have find the maximum gap from 0 to 2. So here the maximum gap is 2. But if you have seen, there is some part still left between 2 to 6 that we haven't considered, and that part's gap is 4. So this gap is 4. So we take, so this is our tail interval. This is called as, this is a tail interval, right? So we have to consider that tail interval also, right? So tail interval is distance between x minus position of previous obstacle, right? So that distance is tail interval. So we have considered our tail interval also. So tail interval distance is 4. Now what we do is we considered the maximum gap of, so from the query we get the answer as best. Let's say the answer is best, and this is tail. So we take maximum of query, that is from 0 to previous obstacle, comma tail is 4, and this is 2. So maximum of 2 comma 4 is 4. So the maximum gap that we get from 0 to 6 is 4, and our block size was also 4. So that block can fit in, right? So we find the maximum block size or maximum gap from here. Then once we find the maximum what we called gap, then we check whether it is feasible to fit the block. It is feasible to fit the block. So we check if best is greater than or equal to size, that is 4 is greater than or equal to 4, then our answer is true. So if you see, what are the 4 steps? First step, we find a previous obstacle. Second step, we find the maximum gap in between 0 to previous obstacle using the segment tree. Then the third thing, that is tail interval. Tail interval is x minus previous obstacle, and then we find maximum of step 2 comma step 3, the answer that we get from here, and the tail interval, and that is, let's say, that is our gap. And the fourth step is feasibility check. So if our gap is greater than or equal to size, then we return true, else we return false for that particular type 2 query. So these are our 4 steps for type 2 query. Now next thing we will see is how we will process type 1 queries. So in type 1 query we have 1 comma x. That means we have to insert an obstacle at point x. But here we are processing in the backward direction. So instead of inserting, we will remove obstacle at x. So suppose we have our current obstacles at point 0 comma 2 comma 7, 0 2 7. So stored gaps will be 2 and 5. Now we have to remove 2. So what will be the steps? So first of all, first step is we will find the neighbors. Of the obstacle that we have to remove. So our obstacle x is equal to 2. So left position is 0, and right position is 7. That is, let's say 0 to 7. So first we will find the neighbors of the obstacle that we remove. So 0 and 7 are the neighbors, right? This is step 1. Then the step 2. So we have gap of 2 is equal to 2. If you see 0 2 7, so gap of 2 is equal to 2. Now 2 has been removed, so we need to make gap of 2 is equal to 0. So we have to update 2 to 0, that is gap at 2 will be 0 because we removed the obstacle 2. So this is the second step, that we make the gap of the removed obstacle x as 0. So we update that. Now the third thing, so we have removed 2. Now we need to merge this gap. So earlier gap of 7 was 5, that is 7 minus 2 5, but now 2 has been removed, so we need to update gap of 7 as 7 minus 0 as 7, right? So we now next step is we merge the gap. So we update the next step, that is 7 with the distance as 7 minus left, that is 0, right minus left as So right neighbor minus left neighbor will be the new gap. So in step 3 we have merged the gap in the segment tree. And in fourth step we remove the obstacle from our set. So earlier in the obstacles we have 0 to 7, so we remove this from the set, so we will be left with 0 and 7 as the obstacles. So what are the four steps? So first step we make gap of, sorry, in the first step we find the neighbors, that is left position and right position of the uh, obstacle that we are removing. In the second step we make gap of x is equal to 0. In third step we merge the gaps, that is gap of right, we update gap of right position to right minus left. And in the fourth step we remove the obstacle from the set. So these are the four steps for removing or for processing type 1 query. So let's see a dry run. So here we have queries 1217264. So first of all what we'll do is we'll insert all the obstacles. So here we have obstacle at 2, obstacle at 7, and we are considering an obstacle at 0. So we have obstacle at 0, 2 and 7, right? So now using these obstacles, so here if you see what is the gap here is 5, gap here is, sorry, here is 2, here is 5, that is gap of 2 is equal to 2 and gap of 7 is equal to 5. Now I'll show you how we'll build the segment tree from this thing, right? How we'll build the segment tree from this. So what we have done is we have taken the first node will store from 0 to, it is 5 into 10 ki power 4, 5 into 10 ki power 4. So we divide it into two parts. So this node will store 0 to 5 into 10 ki power 4 is, so it will store this. Then this node will store from 25,000 to 5 into 10 ki power 4, like it will store the maximum gap in this range. Then we again divide this range, right? So at node 2, that is at node 2, that is range is 2 comma 2, we have gap of 2, so we have stored this gap here, right? And then suppose it has a some parent, so that parent will take the maximum gap from this node and maximum gap from this right node and store the maximum gap at this node and return the maximum gap to its parent. So this way all the nodes will store maximum gap in their range, right? So this way we'll build the segment tree using the gaps. So similarly for 7, suppose we have 7 here, so at node 7 comma 7 it will store maximum gap 5 and return that gap to its parent. So now suppose 2 and 5 have this common parent here, let's assume. So 2 will return the maximum gap 2 and here 7 will return the maximum gap 5. So it will store the maximum gap of 2 comma 5, it will store maximum gap 5 and return that maximum gap to its parent. So in this way we'll build the segment tree, right? So we have built the segment tree, and when we query the segment tree, like this is query 26 comma 4. So here our size is 4, so we find the maximum gap in the range, this is x, in the range 0 to x. In the range 0 to x we find the maximum gap, right? Using doing query over the segment tree. So here if you see what is the largest obstacle that we get 2 in the, from the segment tree we get 2 as the answer. Then so largest complete gap is 2, and the tail part is which is 6 minus 2, that is 4. So if you see we have 0, 2 and 7, and we are querying for up to this part 0 to 6, right? So we query over 0 to 2, so we find the maximum gap over 0 to 2 which will return as 2. So we have ignored this part, so this part gap is 4, so we take maximum of these two. So 2 comma 4, maximum of 2 comma 4 is 4, so best answer is 4. And even our block size is 4, so 4 is greater than or equal to 4, so answer is true for this query, right? So this way we have processed the last query. Now we get a type 1 query. We get a type 1 query. So we need to remove this obstacle. We need to remove this obstacle as we are processing in the backward direction. So here we have 0 to 7. So we are removing 7. So first we will find the neighbors. So left neighbor is 2. Right neighbor, there is no right neighbor for 7, right? And the next step is we'll make gap of 7 as 0. We make gap of 7 as 0. So now I'll show you how we'll update this gap of 7. So in the segment tree, wait, I'll draw the segment tree and then I'll show you. So in the segment tree we have 0 to 5 into 10 to the power 4. Then I have this, it is divided into two parts. So suppose here we have 7 comma 7, left and right is 7 comma 7. So at 7 comma 7 we have a gap of 5. So we find this node, we go to this node and we find. So we make this gap as 0. Then we go to its parent, so its parents will take maximum gap from its left child and maximum gap from its right child. So from right child it will get 0, and let's say from left child it will get x. So it will update its gap, its maximum gap, and return that value to its parent, and then its parent will update that value and will return to its parent. So in this way, all the nodes, that are affected, will be updated, with the new value, will be updated with the new value. So gap of 7 has become 0, right? So this is the rightmost node, that's why there is no need to merge, but suppose if you have removed 2, if you have removed 2 that is if you have removed 2 instead of 7, then we need to merge this gap. Then we need to, first we have to make gap of 2 as 0, and then in the next step we have to make gap of 7 as right 7 minus left, that is 7. So we need to update this also. So if the removed, node is is in middle, or it has left and right, then we need to do two updates. But if it is a boundary points, obstacle, then we have to do only one update, right? So in this way, we'll process the all the queries. So let's move to the code part. So in the code part we have taken a vector int segment to store the segment tree, and we have taken the max value because we are given x and size max value can be 5 into 10 to the power 4. So we have taken that value, and then this is our main function, that is update function. So it has a node, it has left and right, that is the range of the node, then index is basically the index that we have to update, and value is the value by which we have to update the index. So first we'll find if we get the original node, that is left and right range is equal, then we update the value of the node in the segment tree by the new value and we return. But if we do not get the actual node, then we find, suppose we have 0 to 5 into 10 to the power 4. So we find on which side we have this node, either on left side, or on the right side. So which child has this node? So suppose this child has this node, then we go to this child and then again check until we do not get the exact node. So once we get the exact node, then we update the value, and then at the end we update the parent, that is the parent will take maximum value from its left child and right child and then store the updated value to it. And then, so suppose here 7 is there, then 7 will return that suppose this is the parent of 7, so it will take value from left child and right child and then update its maximum gap, and then its parent will take value from it, and then that parent will also update that value. So this is the update function. So next function is query function. So query function helps us to find the maximum gap in a query range. So this is our query range, and this left and right is the range of the node. So first thing, if the node range, if the node is totally out, if there is no overlapping, between the between the query range and the node range, then we return 0. The second case is there is full overlap. There is full overlap. That is the whole node is inside the query range. Then we return the value, or then we return the maximum gap stored at that node. Then the third case, partial overlapping. That is the node value or node range is partially overlapping with the query range, or the query range is partially overlapping with the node range. Then we query both of its child, left child and right child, right? So this is the query function. It has three things: no overlap case, in that case we return 0. Second case, full overlap. In full overlap we directly return the value. And partial overlap, in that case we check the childs, we find the value inside the child. So this is our query function. Then we come to our main function. So in main function we have first declared the size for the segment tree, which is 4 into max plus 1, because that is the total number of nodes that we have in the segment tree. Then we have a set to store all the obstacles, and we have inserted 0 as the obstacle. And then we have iterated over all the queries, and if there is type 1 query, that means we have to insert an obstacle. So we have stored all the obstacles in the obstacle set, because we have to reach to the final state, where in final state we should have all the obstacles, and then after reaching the final state we will process in the backward direction, right? And then we have stored all the positions where we have the obstacles present. We have stored all the positions where we have the obstacles present. And then what we'll do is, then we store the gaps in the segment tree, right? So for that we have called our node 1 whose range is 0 to max, and the index value is position of I, and the gap value is position of I minus position of I minus 1. That is the gap value that we have to store at that particular index, right? So this will build our segment tree for us. Then what we'll do is, then we iterate over the queries from last to first. So if you get a type 2 query, then we have a x and we have a size, right? So we have to find first we find a previous obstacle whose position is less than x, or equal to x, right? Less than or equal to x, so that we can fit the block. So first we find the previous obstacle. So in previous obstacle we find the index value or position of that, right? And then we query the maximum value or maximum gap from 0 to that previous obstacle. So that maximum gap we have stored in the variable named as best. And then I have already explained, this is the tail part. So let me again explain you. Suppose we have 0 to 7, we have three obstacles, 0, 2 and 7, and we are finding 4x is equal to 6 and 4x is equal to 6. So we have queried for 0 to 2, we have queried the maximum gap for 0 to 2, but this part 2 to 6 is the tail part, that is x minus previous obstacle. That part is still left. So it may be possible that we have a maximum gap created here, so we consider that maximum gap also. So that's why we're taking maximum of best is the query part, and x minus previous obstacle is the this part, that is tail part. And then we have taken the best of these two, and then we compare. If best is greater than or equal to size, then our answer is true, else our answer is false. So this is the way we process type 2 queries. Now we'll see how we'll process type 1 queries. So in type 1 queries we have to remove the obstacle present at point x. So first we find the position of that obstacle in our obstacle vector, and then we find the neighbors of it. That is left position, right? And we find the right of it, right? And before that we make gap of x. We update gap of x is equal to 0. And then we check the right of it. So if if the right of it is not equal to obstacle dot end, that means our current obstacle is present in between, so we have to merge the gaps. Suppose we have 0, again 2 and 7, and we have to remove 2. So we need to merge the gap between 0 and 7. So this part is to merge the gaps. So we are updating the right position, that is we are updating the right position with the new gap, that is right position minus left position. So earlier gap of 7 is equal to 7 minus 2 5, but now gap of 7 will be 7 minus 0. So 7 is the right of 2 and 0 is the left of 2, so that's why see we are updating the gap. And then at the end we erase the obstacle from the obstacle vector. And then at the end, so here we are storing the answer in the reverse direction, so we need to reverse our answer and we return our answer. So this is the whole explanation. So I hope you get the solution. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.